Lieborg, you were going to ask something.
Oh yeah, I was gonna ask you. I had no idea your background was not technical. I just make random assumptions. So I was kind of wondering, was there a project that you were involved in, or did, or saw even, that like really made you fall in love with electronics? Like something that like really captivated you about it?
Electronics specifically? That's a really good question. So the first sort of electronics-like projects that we did were LED projects, stuff to light up our bikes when we were dressing them up for events and so on. So that was much more about display than about electronics themselves.
That's okay. I mean,
that's
a good.
That totally qualifies.
Yeah,
for sure.
And then so the other like super inspirational project from a different direction was seeing Bathsheba Grossman's sculptures at Maker Faire. Sorry, I don't know if you're familiar with her work.
No,
I don't think so.
So she is a sculptor who works primarily in 3D printing, and if you'll hang on for just a sec, I'll grab a piece.
Yeah.
Ooh, yeah, absolutely. Absolutely.
Totally. It had me thinking about like when I was in school and I took like this class called like electronics for artists, and we had to make a switch. We could make a switch out of like anything conductive. I still make my students do this, and I had no idea what I was going to do, and I ended up making a switch out of a pineapple, and you like put like the head of the pineapple on, and the LED would turn on, and I was like, whoa, electronics can be anything. And I think of like that as my origin moment, so I'm just kind of wondering.
I love it.
Okay, so
pineapple electronics. I want to make a circuit out of pineapples.
So this is one of Bathsheba's pieces. So this is made out of sintered metal, and it's
that's
mathematically complicated, right?
Whoa.
It's just really beautiful, super satisfying to hold, and absolutely gorgeous. So we saw her work at the very first Maker Faire back in 2006, and we're just smitten. And so that's when we started working on the Candy Fab project, making a 3D printer that worked with sugar as the printing media. So that got me not so much into electronics as into mechanisms. And because we did things like the Z stage for the original Candy Fab. So the vertical motion system for that was made out of a car jack that we had turned into a servo motor to lift a large volume of sugar up and down, plus the wooden bucket that held it essentially. So it needed to be able to lift a lot of material very precisely. So the types of mechanisms that we used for that were all fun and repurposed and interesting. We actually used pen plotters for a lot of it, because you could get the old HP pen plotters at the surplus stores for next to nothing, and they have, linear shafts and motion control stages that are of wonderful quality. And so we did a lot of repurposing. As we moved forward with the project, we started trying to recreate those types of designs and build something that was manufacturable from scratch, which is a lot harder in some ways. But it's very hard to give someone instructions to make something from, I found this at a surplus store.
Yes.
Yes.
Pretty sure it works like this. But...
so you need a model. No. Yeah.
I just totally thought of an engineering use for pen plotters, which I have actually done before, which is you can use them to plot circuit boards on copper clad substrate and etch your own circuit boards with them.
Yeah, so that is something that people have done with AxiDraw. The other way that you can do that is actually with a conductive pen. You can just draw your circuit instead of etching it. And so people have done that with AxiDraw and with Eggbot as well, if you need a spherical circuit.
If you need a conductive egg,
yes,
got you covered.
Way easier going from Eggbot to pen plotter that just has two axes? No,
because the Eggbot is essentially direct drive. So you have a motor that's turning the egg, right?
Yeah.
and you have a motor that's just turning the pen, just moving it in an arc over the egg.
Mm-hmm.
There's no intermediary hardware, or very little. For the pen, there's a servo motor that just lifts and lowers. So
is it spring kind of loaded to keep touch with the surface of the egg, or
no? It's gravity driven. So it's lifted away from the egg and then lowered to just right along the surface of gravity.
Got it.
And that's that's true with the Axidraw as well. The watercolor bot had powered down. It would press the brush down because you need to be able to push the brush onto the paper. But the Axidraw and the Eggbot were both just gravity driven.
Nice.
So no, all of the other types of motion control that we've done are more complicated because you need some kind of hardware to translate it into those positions. The Axidraw does not have any moving motors. Neither did the watercolor bot. So the watercolor bot used an Etch-a-Sketch style motion system with essentially cords that pulled the stages around. And the Axidraw uses a single belt that's connected to both motors, or to two motors. And so neither of those is specifically X or Y. It's a combination of them that drives it to the correct location. So those are much more complicated than the Eggbot, which is just a direct. We have rotation and we have pen, and that's it.